Hello my dears, how are you all? I think corona is now decreasing, right? Nowadays it's slowly declining, its number declining, patients number. So let's hope for best, and soon let's hope for soon it will completely over and our examinations will come, and because we are almost in a right way in order to get a good exam. So if you get a good exam, then we will definitely do something. So let's pray together so that everything will be normal as soon as possible. Okay, so that's all. So let's come to the point. So in the last class we discussed about some important problems regarding the transients, right? Important problems regarding the transients, and in some funny manner, for some funny manner we learned something. See, these funny things, you may sometimes you may feel like, oh, why is sir telling this? Telling this like, maybe you may feel like that, but the fact is that if you are a serious professor to take these transients, I guarantee you will definitely sleep. You would definitely sleep in between, because this is such a subject. This is such a session, especially not a subject actually. It's such a session, especially transient t greater than 0, t less than 0, t equal to 0. No, at that time definitely you will fall asleep. So that's why I made some my own way in order to deliver this content, and some funny manner also, right? So take it in a positive spirit, right? Okay, that's all. So let's do some more problems so that the idea will be more and more concreted. Then only we will do any problem, right? If we will do any problem means it's like, it's overconfidence, right? At least we can try any problem. That is the correct word. Okay, I will do any problem means it's like overconfident, right? We don't like that, right? So we will try any problem. That's the correct word in my view. Okay, so let's do some more problems regarding okay. Did you feel interest while doing these type of transients problems? Sincerely answer. Okay, you can comment your answer sincerely. Write a question, beta. Write a question. Find IC of t. The question is, find IC of t at t is equal to 2 seconds, t is equal to 2 seconds, comma, initial charge across C is is 5 coulomb. 5 coulomb. Okay, so this is our question. This is our question. Read the question carefully. Read the question carefully. What is that? What is that? There is again a circuit, and we have to find IC of t. It is nothing but the current through the capacitor, right? The current through the capacitor we have to find. At t is equal to 2 seconds, initial charge across C is 5 coulomb, right? Initial charge across C is 5 coulomb. So from where we have to start our analysis? At t is equal to 0 minus. Similarly, so at t is equal to 0 minus. So T is equal to 0 minus, what is the purpose of doing T is equal to 0 minus condition beta? It is in order to get the initial charge, initial voltage across the capacitor and initial current across the inductor. That is the main purpose of doing at a T is equal to 0 minus condition. Okay. So see, at a T is equal to 0 minus here, the switch is in closed position or open position. The switch is in open position at a T is equal to 0 minus, because only at a T is equal to 0 the switch is closed. Before that is represented by 0 minus. Before doing the switch operation is considered to be the 0 minus. So before doing the switch operation means again the system is in some type of steady state, and at a T is equal to 0 minus means the switch is in open position. Open position means this 20 volt will not be there, right? Open position means this 20 volt will not be there. This is isolated from the supply, right? But we can say that the circuit diagram will be simply what? 1 farad, right? This is like open circuit condition, right? And the voltage across this capacitor is nothing but beta Vc of 0 minus, correct or wrong? The voltage across this capacitor is nothing but Vc of 0. That is the purpose of doing 0 minus condition. Since there is no source, we can't say that there is some voltage, but it is given that the initial charge across the capacitor is 5 coulomb. The charge, voltage and capacitance relation is nothing but Q is equal to CV. You heard that, right? See, Q is equal to CV. From this, V is nothing but Q by C. That means Vc of 0 minus is nothing but initial charge divided by the capacitance value, which is nothing but 1 farad. That means 5 volt. So this is the initial voltage across the capacitor, right? So what is the difference of this problem with respect to the previous problems is that these problems contains the initial charge of capacitor, but in all the previous problems, if it is open circuited means simply you can take Vc of 0 minus equal to 0 volt, because there is no source to provide some voltage, right? But here in this condition, the initial charge is clearly given like 5 coulomb. If it is some charge there in the capacitor, definitely that charge to be released in the form of what? Current, so that there will be some voltage, right? So that voltage is nothing but 5 volt of voltage, right? 5 volt of voltage. Bus. So you got Vc of 0 minus, right? Okay. And next, what is our next step? We have to do at a T equal to or T greater than 0 condition, right? T greater than 0 condition. At a T greater than 0 condition, what will be the circuit diagram? This 20 will be included, right? Because at T equal to 0 means, T greater than 0 means it will be closed, right? This switch will be closed, right? So that there will be a connection. So this will be like this. So this is nothing but Vc of T and 1 farad and 4 ohm, and this is nothing but 20 volt. And what will be at T is equal to infinity? What will be at T is equal to infinity? T equal to infinity is nothing but the final steady state condition, right? So at that time the capacitor will be what? Open circuit and inductor will be short circuit. C will be open circuit and L will be short circuit, right? C will be open circuit and L will be short circuit at T is equal to infinity. So our figure will become and one more thing, beta, at T greater than 0 means the capacitor should be represented with like the capacitor in series with a voltage source, right? This voltage source is nothing but the initial voltage, right? 5 volt. Okay, you should write that. Then only the exact, concept will be exact, clear. Okay, initial voltage capacitor. And see, at T equal to infinity means again this capacitor will be open circuited. So now you have to think that if the capacitor is open circuit, then what happened to this initial voltage across the capacitor? Let's do some analysis here. Suppose this is the figure, right? This is the figure. And this is the capacitor. This was our initial condition, right? This is 1 farad. Okay. Let's focus on this session. Let's focus on this session. If you open circuit the capacitor, open circuit means what, beta? Open circuit means what? Open circuit means the resistance here will be what? R is equal to infinity. Correct or wrong? The resistance in the path will be what? Infinity. And that infinite resistance in series with some resistance of the voltage, right? Voltage was also having some voltage, right? So that infinite resistance in series with some resistance value, maybe high value of resistance. Suppose it may be 10k or 20k something. You may assume like that. So this is equivalent to an infinite resistance. So let again it be like this. So this is equal to R is equal to infinity. Let R is equal to 10k or 5k. So what will be the effective resistance there? What will be the effective resistance? It is equal to beta some resistance of infinite resistance in series with another resistance of high value, means the overall will be the addition. If you add something to the infinity, your result will be what? Infinity. That is, R equivalent will be equal to what? Infinity. R equivalent infinity means the overall condition is similar to an open circuit condition. Open circuit condition. That means at t is equal to infinity, this capacitor section is completely like open circuited, and the final voltage is nothing but Vc of infinity across the capacitor. The capacitor itself like to be an open circuit condition. The reason is that beta, I will tell you one thing, these things now you can't see in textbook. These things now you can't see in textbook or whatever book you are going to read. They simply write at t greater than 0 it is the condition, at t is equal to 0 this will be the condition. They don't know, I don't know, they know definitely because they are big authors, they definitely know, but they don't explain how this happened. Okay, so this is how it actually obtained. These things now you have to, only these things will come into your mind if you really know this concept. If you really know this concept in your mind, then these things will be automatically come. That means even if you even the author or the book directly write these steps, you have to clearly know that, oh, this is the reason. That level of thinking you should have. Okay, so that is the condition. So it will be open circuit, then voltage will be nothing but beta. What will be Vc of infinity here? Since it is open circuit means there will not be any current, right? That means it is simply that this effect of this forum will not be there, right? Because there is no current. If there is current means the effect will be there regarding voltage, but there is no current means this effect of forum will not be there. So Vc of infinity will be simply 20 volt. Vc of infinity will be simply what? 20 volt. Can I have this? Okay. So our aim is to find Ic of t, right? Before Ic of t we have to find a Vc of t, then only Ic of t will come automatically, right? So Vc of t is nothing but beta. Here it contain only RC, right? R and C. So definitely we can seek the help of the equation. Source at a t equal to 0 means there is an inclusion of source, right? So it is a sourceful RC circuit, right? It is a sourceful RC circuit, right? It is a sourceful RC circuit, right? It's a sourceful RC circuit, right? So Vc of t will be equal to Vc of 0 minus Vc of infinity into e raised to minus t by RC beta plus Vc of infinity. This is the equation. You know this, right? You already know this. I already did this equation, right? Noted this equation, right? So Vc of t will be equal to Vc of 0 minus Vc of infinity into e raised to minus t by RC plus Vc of infinity. That is the equation. So you have the value of Vc of 0 now. You have the value of Vc of infinity now. What is the value of R equivalent? R equivalent is nothing but beta. With respect to capacitor, what will be the resistance here? With respect to capacitor, what will be the total resistance? Simply R only. This is nothing but 4 ohm. So you can apply this in equation, that is Vc of t will be equal to, Vc of 0 is what beta? 5, right? 5 minus 20, right? E raised to minus t by 4, because C is 1 farad, right? So simply 4 plus Vc of infinity is again 20. So this is the equation for what? Vc of t, right? Or I can write like minus 15 e raised to minus t by 4 plus 20. Correct or wrong beta? Correct or wrong? So that is the equation for Vc of t. Minus 15 e raised to minus t by 4 plus 20. If you have Vc of t in your hand, then Ic of t is very easy, right? Because in a capacitor, Ic of t is nothing but beta C into d by dt of Vc of t. So now you understood why I have to do this Vc of t, right? In order to get Ic of t, that is my aim. So what is that? C is nothing but 1 and d by dt of what is Vc of t beta? Again minus 15 e raised to minus t by 4 plus 20. So it will become minus 15, you can take as constant, so minus t by 4 into minus 1 by 4. So it will become 15 by 4 e raised to minus t by 4. Correct? But we have to find Ic of t at t is equal to what beta? 2 second, right? So which is nothing but 15 by 4 e raised to minus 2 by 4, which is nothing but 15 by 4 e raised to minus 1 by 2. So that is the answer. That is the answer. Let's check the answer. Correct. Correct. So that is the final answer. That is the final answer. Is it clear better? Is it clear? See, definitely this type of big question will not be asked in RRB JE or SSC JE's like examination, but a portion of this will be asked. A portion of this may be t greater than 0, what will be the value, t is equal to 0, what will be 1. A portion may be asked, okay. This type of long 1, 2, 3 step, right, like long problems will not be asked generally. If you are preparing for gate like examination, definitely this will be asked, right? These type will be asked. 2 mark question there will be there, so definitely this type of question will be asked. But for RRBJ, SSCBJ, and of course Kerala, PSC, KCB, sub engineer and all, this far away from their concept, right? Far away from their, standard of questions. No, this is very high standard questions actually. So we will not expect this type of question there. But if you do this type of question in classroom, no, you will have a confidence that any question if you ask in your lower level of exam, lower level in the examination all are high level, but lower level means compared to gate and all UPSC and all, lower level means state level examination. So this type of question will be easily you can answer. Okay. So can I wrap this? Can I wrap this? Did you get the idea, beta? Did you get the idea now? Did you get the idea now? Okay. Regarding transients, you don't need to practice other questions because sufficient problems I did in class itself regarding transients. No need to tensor. Okay. Write a question, beta. Write a question. A very standard question we are going to do. Find IL of t. Yes, that's our question. That's our question. you have to find IL of t. Again, it's an RL circuit, no? So definitely you can use the equation of sourceful RL circuit equation. IL of t will be equal to, what is that? IL of 0 minus IL of infinity into e raised to minus t by tau plus IL of infinity. You can use that. But again, our analysis will start from at t is equal to 0 minus condition, right? These steps now, these steps you can follow for all questions regarding transients. Definitely you will get some data, initial condition and all, definitely you will get, okay. So what is the purpose of doing at t is equal to 0 minus? Here we have to find IL of 0 bus, okay, that's the aim. So listen very carefully. The input is nothing but a unit step function, but a combination of unit step. 10 into u of minus t means u of t generally beta, this is the u of t, right? So this is u of t, that is it will exist only for t greater than 0, right? U of t will, that is f of t will be equal to u of t, this is u of t, this is f of t will be equal to u of t for t greater than 0, right? And it will be 0 for t less than 0, and its value will be u of t plus 1 plus 0 divided by 2 for t equal to 0. That things you know this, right? You know these things. What will be u of minus t beta? U of minus t is nothing but exactly opposite to the u of t. So this is u of minus, and definition of u of minus is nothing but beta. Listen carefully. F of t will be equal to u of minus t for t less than 0 and 0 for t greater than 0, and 0, and it will be, value will be u of minus t plus 0 by 2 for t equal to 0. That is the condition. That means u of minus t is a signal which exists only if t less than 0. Only for t less than 0 that exists. Okay. Only for t less than 0 that exists. But t equal to 0, no, there are also some values there, but for our analysis that also need not directly, because I will explain. So u of minus t is nothing but a signal having value of u of t for t less than 0. That means its value will only exist for t less than 0 bus. So at t equal to 0 minus means, it is less than 0, right? It's less than 0, right? At t equal to 0 only there will be switching operation and there will be transients. 0 minus means before t equal to 0. That is the condition of 0 minus. So at t is equal to 0 minus, from the source side this will not be there, right? Because this will be exist only for t greater than 0. But you have to know, you have to consider for at t equal to 0 minus means t less than 0. So this will be only for t less than 0 condition. So again, this is a t is equal to 0 minus mean, this is also a steady state condition or stable condition. For that stable condition, the switch is in closed or open position. The switch was in closed position, right? At t is equal to 0 only it opened. So before that it was in closed position, or it is in short circuited condition, right? It was in short circuited condition, right? So, and of course we know that the inductor will be short circuited under stable condition, right? Stable condition. So our circuit will become, very carefully listen, 10 volt. So 10 into u of t means it is simply 10, right? 10 into u of t means it's simply 10, right? So because I already told you that x into u of t means its magnitude, right? Its magnitude. X into 10 into 5 into del of t means it's what? Area, and 3 into r of t means 3 is its slope, right? I already explained that. So 10 volt and it is 1 ohm will be there, and it will be short circuit, right? And these also short circuit mean this portion also short circuit condition. So this will be the right condition. So this current will be nothing but IL of 0 minus. IL of 0 minus beta. And what will be IL of 0 minus here? IL of 0 minus here. IL of 0 minus is nothing but 10 by 1. 10 ampere. 10 ampere. Is it clear? Is it clear beta? So that is the condition for at t is equal to 0 minus. And next is nothing but at t greater than 0 condition. So at a t greater than 0 means from the source side, this 10 into u of t, no, 10, this will not be there, because this is only activated for t less than 0, but this only will be there for t greater than 0, because this is 20 u of t, because u of t we know that it only exists for what, t greater than 0 condition. So when t greater than 0, this will be only the source side, this will not be there, and we can draw that first. So 20 will be there, right, and everything will be right, everything will be there, and the switch is in closed open position now, so 1 ohm also there. So this is open position, so 1 ohm also there, 1 Henry also there, 1 ohm also there, this is 20. So this is the condition for t greater than 0, and you have to introduce this current, right? So you can introduce this current as, because when you looking for t greater than 0, you have to consider the initial current across the inductor, that is 30 . So this is the complete diagram of what, t greater than 0, t greater than 0. Again we have to find what, again at t equal to infinity, right? Then only you will get the IL of infinity side. So this is t greater than 0 condition, general condition, and from this you have to derive the condition for at t equal to infinity. What changes will be there? You already know that at t equal to infinity means this is also a type of stable condition, right? This is also a type of stable condition. So that stable condition is nothing but the inductor will be what, short circuited, and capacitor will be open circuited. So again I have to write open circuit. So the figure will become, better listen carefully, the figure will become 20 is 20 like that, and it is 1 ohm is like that. This inductor is short circuit means this combined effect will not be there, simply short circuit condition. I already explained now this condition, and this is nothing but IL of infinity, right? IL of infinity. So what is the value of IL of infinity here? 20 divided by, this is also 1 ohm, right? Again 10 ampere. Correct, beta? Correct. So you got the value of IL of infinity also. Then what will be IL of t? An interesting thing you have to note this. IL of t is nothing but IL of 0 minus IL of infinity e raised to minus t by tau, right? T by tau plus IL of infinity. And what is tau here? Tau is nothing but L by R. R is the effective resistance with reference to the inductor side, right? So with respect to the inductor side means R will be equal to what? Total R will be equal to what, beta? With respect to inductor side. So considering for this inductor, what will be the total resistance feel by that inductor? 1 plus 1, 2 ohm, right? Because as far as, or as consider the side of an inductor, the inductor feels 1 ohm first, and you have to, I will say a trick to find this. Suppose you send a current from this side, this same current will be flowing through this, the same current will be flowing through this. That means these all in series. So as far as the inductor side, the resistance will be nothing but, R equivalent will be nothing but beta 1 plus 1, it is nothing but 2 ohm. 1 plus 1, which is nothing but 2 ohm. Okay. So it will be what will be the answer? What will be the answer? So L by R is nothing but, L is nothing but what, 1 Henry, right? So 1 by 2. 1 by 2. So our equation will become, listen carefully, IL of t is nothing but, IL of 0 is what? 10. IL of infinity is what? Again 10. So it will be 0 plus IL of infinity is nothing but what? 10. A very interesting fact you can observe here, that current, inductor current in this specific circuit is independent of time. Independent of time. IL of t will be equal to 10 ampere. That means whatever the value of t, the current will be 10. The current will be constant. The current will be constant. That means this is nothing but, it is like a perfect DC source now. Perfect DC source of having a current of 10 ampere. Is it clear? So that is the peculiarity or interesting thing you should note from this problem. Okay. So that's all about that question. So did you get the idea? Did you get the idea, beta? Did you get the idea? Okay. Can I run this? Can I run this? Okay, one more question you can write. One more question you can write. Find VC of t. Find VC of t. Very, very interesting thing. Find VC of t beta. That is our question. Draw this figure. Draw this figure. Draw this figure. Okay, how can we do? How can we proceed with? Again, a similar manner. At t is equal to 0 minus. You can start from that point. So at t is equal to 0 minus, listen very carefully. From the source side, 13 to u of t will not be there, right? Will not be there because u of t exists only for t greater than 0. This is the condition at which t less than 0, right? So there will not be any source side voltage. It will be open circuit or closed short circuit. That's my question. It will be short circuit or open circuit. There is an idea for that also. If there is no voltage, means voltage is 0. Voltage is 0 only when it is a short circuit condition, right? It will not be an open circuit. That you should not. That you should not. So doing these problems now, doing this transients problem, you will get enormous type of concept from this. Many concept you can learn from these questions. That is very, very important, or that peculiarity of the transients, because you can really learn what electrical engineering is. What electrical engineering is. Normally these type of problems, no, normally some teachers will simply skip this topic, no, by thinking that this will be very confusion, making confusion and all, and they are also feel very difficult to understand the concepts. Students also definitely. So that's why normally they skip, or they take it in the last session, no, after all the portions completed, this will be taken. But what I mean, or my aim is that you should know the tough things initially. You should know the tough things initially. Then only the things later will be easy for you. That's my aim. That's my aim. That's why I took circuit theory as first subject. Okay. And because machines, power system, or all will be easy with compared to the circuit theory. Circuit theory is the most difficult subject in electrical engineering, because many type of question will be asked. Different type of question will be asked. We can't predict. But machines, as far as machine, there will be some theory. You simply learn the theory, you can do the problem. Power system also, some formulas will be there, you can do the problems. But circuit theory is not. The examiner, depending upon the knowledge of the examiner, the question will be very difficult or simple or moderate. It will depend. Clear? So, up to the point. At t is equal to 0 means this portion is simply a short circuit condition. Simply a short circuit. And there will be 10 ohm, right? There will be 10 ohm. There will be 20 ohm, no doubt in that, right? And of course there will be The capacitor will be what? Open circuit now. So the capacitor will be simply open circuit. Because t is equal to 0 minus also what? T is equal to 0 minus also, it's a steady state condition. So capacitor will be open circuit. And very important thing you should note here that at t is equal to 0 minus means this switch was in closed or open position. The switch was in closed or open position. This was in closed position beta. At t is equal to 0 minus means this is in closed position. This is in closed position means there will be a voltage. So now you have to find the VC of 0 minus, right? VC of 0 minus. You can easily do from this also. VC of 0 minus means up to this end, right? From these two ends voltage, right? That is nothing but these two end voltages. So VC of 0 minus is nothing but 10 volt, symbol. Okay. So next, what we have to do? T is equal to t greater than 0 condition. At t greater than 0, listen very carefully better. T greater than 0 means, what is that? From the source side, t greater than 0, the 30 will be there, right? 30 will be there. And see, I will draw. So from the source side, that 30 volt will be there. 30 volt will be there. And 10 ohm will be there, no doubt in that. And 20 ohm will be there, there is also no doubt in that. And the capacitor can be represented like a capacitor in series with a voltage, right? So it is nothing but 10 volt, right? So C of 1/4 farad, right? And there is an inclusion of voltage, right? There is an inclusion of this voltage by closing. Sorry, there is exclusion, right? Sorry. At t is equal to 0, t greater than 0 means the switch is in open position, right? The switch is in open position means there will not be any what? 10 volt, right? So this will be simply open circuit condition, right? So it will be simply open circuit condition. So this is for at t greater than 0 beta, t greater than 0. And now we have to find at t equal to infinity. So again t equal to infinity is another type of steady state, right? Another type of steady state. So there will not be what? Some effect there will be there, that is nothing but inductor will be what beta? Inductor will be short circuited and capacitor will be open circuit. Clear? Inductor will be open circuit, short circuit, and capacitor will be open circuit. So if you open circuit this capacitor means again the same thing will happen now. There is no effect of this 10 volt, right? Because infinity will be the resultant resistance. So the figure will become the capacitor will be open circuited and there is exist a voltage of VC of infinity, and this is 20 ohm, this is 10 ohm, this is 10 ohm. Is it clear beta? Then what is VC of infinity? Apply voltage division rule, because 30 volt is applied across the series connection of 10 and 20 na. So what will be VC of infinity? It is nothing but 30 into 20 divided by 20 plus 10 is nothing but 30. 30 and 30 get cancelled. So VC of infinity will be what beta? 20 volt. 20 volt. VC of infinity will be 20 volt. So now you got the value of VC of 0 and VC of infinity, right? So we have the equation of VC of t is nothing but beta VC of 0 minus VC of infinity into e raised to minus t by RC plus VC of infinity, right? Plus VC of infinity. Plus VC of infinity. So you know what is the value of this R here? R is nothing but, R equivalent is nothing but, with respect to the capacitor side, with respect to the capacitor, what will be the effective resistance? That is the meaning of R here, the time constant R here. So with respect to this capacitor, this is in parallel, right? And these also in parallel, because whenever we are dealing with the resistance, or it is nothing but Thevenin resistance actually. Voltage short should be short circuit, right? So if this short circuit means this will come like this and connect here, and this is also here. So 20 and 10 will be in parallel condition with respect to the capacitor. So R equivalent will be nothing but 20 parallel to 10, right? So it is nothing but 20 into 10 by 30, right? So it will be 3. There is nothing but 20 by 3 ohm. So that is nothing but R equivalent, right? So listen very carefully. So what will be tau now? Tau is nothing but RC, which is nothing but 20 by 3 into, what is the value C beta? What is the value C? It is nothing but 1 by 4, right? So it will be 1 by 4. So it will become simply 5 by 3 tau. Tau is R into C, right? R into C. Time constant. To constant means there is no unit, right? So 5 by 3. So what will be that? What will be that? Definitely time constant means it has some unit, right? Because R has some unit of ohm, C having farad, so ohm farad will be the unit, but normally we are not using that. Simply tau is equal to 5 by 3. Okay, so what is the final equation of VC of t beta? VC of t will be equal to VC of 0. What is VC of 0? 10 volt, right? 10 minus, simply VC of 0 means VC of 0 minus, that's all. Okay, 10 minus, what is VC of infinity? 20. Okay, e raised to minus t by RC. RC is nothing but 5 by 3, right? 5 by 3 plus VC of infinity is nothing but beta. What is that? 20, right? 20. So the answer will be 10 minus 20 is minus 10 e raised to minus 3t by 5, right? Plus 20. So these will be the answer. VC of t is minus 10 e raised to minus 3t by 5 plus 20. Yes. So that's all about the question. So that's all about the transients. Okay. So that's all about the transients. And next we are going to do something with the Laplace transform. Very, very important. So I think you get this. You get this. Is there any doubt? Please mention in the comment section. Regarding the transients problem also, you can personally contact me if you have any doubt. Okay. My phone number is in the description itself. You can contact that. It's my WhatsApp as well as call number. This is my number. 8075 111 798 is my number. If you have any query or if there anything I made a mistake here, you can directly call to this number and tell me. I will correct it. Because mistake now, everyone, chances of mistake are there for everyone, right? So this is my number. You can call to that number. Okay. Did you copy this? Did you copy this? Did you copy this beta? Okay. So did you copy this? Can I rub this? Can I rub this? Okay. Next you have to see Laplace transform. Laplace transform means it's a tool in electrical engineering or in mathematics, simply in mathematics, so that you can convert time domain to S domain. So that is the importance of Laplace transform. You can convert any time domain to S domain. And the definition of Laplace is, suppose a function in t domain is in f of t, let it be f of t, and its Laplace transform will be nothing but f of s. And the definition of Laplace transform is nothing but, f of s will be equal to beta 0 to infinity e raised to minus ft f of t dt. Very, very important. Actually, you don't need to use this integration and all for problem. We have some standard equations and all, formulas and all, we can directly apply that, but this is the definition. That means Laplace is a tool to convert the time domain to frequency. So omega S domain. S is nothing but j omega, but S is nothing but j omega. S is nothing but j omega, or time to frequency domain. You can say in that manner also, omega equal to nothing but 2 pi f now, 2 pi f now. So you can say that also. So Laplace transform is a tool in mathematics in order to convert any time domain to S domain. What is the purpose of doing this thing? See the limit integration, see the integration limit 0 to infinity, right? That means if you take this into Laplace transform, it covers only for t greater than 0. So many of the problems regarding t less than 0 conditions and all, you can easily solve with respect to this Laplace transform. There will not be that much complication. There will not be that much confusion if you do some problems in Laplace transform instead of that t time domain analysis. Okay, that we will definitely know after doing some problems in here in Laplace. We will definitely clear what is the use of or what is the purpose of Laplace transform. You will definitely get the idea. So that's all for Laplace definition and all. And there is inverse Laplace transform also. That is nothing but f of s is a Laplace transform as the function f of t. Then inverse Laplace transform is nothing but is f of t. Okay, that also you can do by using this integration. So this is the concept, simple concept of Laplace transform. I think you already studied mathematics, no? First year mathematics contained this Laplace. So first year or I think third semester, right? This contains Laplace transform. It's very interesting actually. So how many problems are there? But as far as the electrical concept, no, electrical view, we don't need to fully cover those things, but we just need some formulas and some equations for easily solving a problem in Laplace transform. So you can make a table that is very useful table. The table contains some function and its Laplace transform. Very, very important table. Very, very important table. Okay. Very, very important table. That is, the table contains time domain function and Laplace transform. Time domain function and its Laplace transform. Okay, you can draw this. Let f of t will be equal to del of t. Sorry, a into u of t. A into u of t, and its Laplace transform will be a into u of t is nothing but simply a, right? Constant. So the constant Laplace transform will be simply but a by s. And second, f of t will be equal to simply u of t means if Laplace transform will be equal to 1 by s. 1 by s. And f of t will be equal to del of t and f of s will be equal to, very, very important, the Laplace transform of del time in what? Impulse response, right? Impulse signal is nothing but f of s equal to 1. And f of t is equal to a into r of t. For that, a into r of t, which is nothing but a by s square. That means r of t having Laplace transform 1 by s square, because r of t is nothing but beta a into t na. R of t is nothing but t, right? T, right? So a into t means f of t a by s square. And next, f of t is equal to simple r of t. R of t is nothing but beta t, right? For that, f of s will be equal to simply 1 by s square. And another thing, f of t is equal to t raised to n, then f of s will be equal to n factorial divided by s raised to n plus 1. Very, very important. f of t is equal to t square. You can apply this equation, right? F of t's Laplace transform is nothing but n factorial divided by s raised to n plus. For t square meaning n equal to 2 na, so it will be 2 factorial divided by s raised to 2 plus 1, which is nothing but 3. 2 factorial is nothing but 2, right? 2 by s cube. What is the meaning of factorial means? Suppose you have to find 5 factorial means, simply multiply the x's. That's all, 5 factorial. You have to write x factorial means, x factorial, okay, that will be make confusion. So, okay, we will do that also, no issue. X into x minus 1 into x minus 2, etc. up to x minus of n minus 1 into 1. So, that will be the factorial. So, less 1 into multiply together. So, 4 factorial is nothing but 4 into 3 into 2 into plus. That's the concept of factorial, right? So, another will be e raised to minus at 1 divided by s plus a e raised to at 1 divided by s minus a ten e raised to at. What will be that? 10 divided by s minus a. Okay. Sin omega t. What is the Laplace transform of sin omega t? Omega by s square plus omega square. Cos omega t. F of s will be s divided by s square plus omega square. T raised to minus alpha t one divided by s plus alpha the whole square. Okay. If you write this, I will rub this. Okay. Okay, I will make it in this session. No issues. That side also I will write. That side also I will write. Same. It is 13 and I think it is 14, right? So t will be equal to t raised to alpha t. And the result will be f of s is equal to 1 divided by s minus alpha the whole square. F of t will be, you have to write this equation because it's very very important. You have to by heart this, okay? E raised to minus alpha t sin omega t. F of s is nothing but beta omega divided by s plus alpha the whole square plus omega square. 16. Sin h alpha t. Alpha divided by s square minus alpha square. F of t is equal to cos h alpha t. And f of s is nothing but s divided by s square minus alpha square. 19. d by dt of f of t. Its Laplace transform will be s into s into f of s minus f of 0. That is, f of s means this functional's Laplace transform. F of 0 means apply the 0 condition to this function. Okay, that is the difference. F of s will be s square into f of s minus f of 0 minus f dash of 0. See, small f is nothing but this function. Capital S is for Laplace transform. Okay. Integral f of t dc, for that Laplace transform will be f of s by s plus f of 0 by s. F of 0 by s. This is small f, right? This is small f. Small f. And Laplace transform of suppose f of t is nothing but t raised to n into f of t. For that, the Laplace transform will be minus 1 the whole raised to n into d by ds, d raised to n by ds raised to n into d raised to n and ds raised to n into f of s. That's all. Okay. So that is the main equations connecting the Laplace transform and the time domain. You have to by heart this. You have to by heart, because applying that e raised to minus s into f of t d2 now, you don't get time for that doing. So better you have to by heart these 22 equations. It's very, very important. By doing some problems now, it will be very helpful. I will explain. Okay, you have to some examination now, directly you can see what is the Laplace transform of t raised to n, what is the Laplace transform of t square now. Directly you can have some question from here only. Directly you can expect some question from here. Time domain and its Laplace transform. Okay, so it's very, very important table. You have to by heart it all. Okay, so that's all for today. So in the next class onwards, we will do some problems regarding this Laplace and more. Okay, so that's all for today. So thank you all. So keep doing work and revise. Keep revise our sessions regularly. Then only more and more confident you will get. Okay, so that's all for today. So bye.